In this video, we're going to continue topic 8.2 on position, velocity, and acceleration, and we're going to talk about speed. So we know that the speed is increasing when velocity and acceleration have the same sign. And speed is decreasing when velocity and acceleration have opposite signs. So you got to make sure you understand that speed is acceleration and velocity, whereas moving towards or away from the origin is position and velocity. It's always velocity, you just have to make sure you pair it with the right one. So we've got a particle so notice we get to use our calculator, so that means, hey, let's put it in. Let's put it in now, okay? So that would be t cubed, so x cubed, and then minus 10x, and it was 10x squared, and then plus 27x, and minus 15. And hit enter. And I really don't care what it looks like. I'm just going to go, I'm going to even hit the calculator page because I know I'm not going to look at the graph probably. I'm just going to go right to calculating here in a minute. All right, so for a particle with velocity, v of t, when is this particle's speed increasing? So literally what you're going to do we need to look at the velocity. So I'm going to evaluate the velocity. Ooh, it says when is the speed increasing? So ultimately, what I need to do is I need to do a sign chart on this. So I'm going to have to find the velocity and the acceleration, which means I'm going to need these critical numbers, okay? So I'm going to go to Menu, Analyze Graph. I know this is my velocity graph. And go to the left, go to the right. I know one of my critical numbers is going to be 0.746. So really this is what first thing we've done is really set the velocity equal to 0 to find the time. So 0.746. Then my next one, Menu, Analyze Graph, 0 to the left, to the right, 0.3480, 3.480, and then Menu, Analyze Graph, 0 to the left, to the right. That one says 5.773. It's probably safer to write down more decimals than that. I also need to find out when the acceleration is equal to 0. So I'm going to do that next. So actually, it's probably not a bad idea for me to take this graph and put it into my notes here so I can continue to see it. Let's set it over here. Okay, I'm going to make it just a touch smaller. Okay, now let's go into here again. And I'm going to tab. I know to get from acceleration or velocity to acceleration, I'm going to turn the blue one off. I just need to take the derivative. I went the wrong way on that. I'm going to take the derivative of my velocity, and I know it's going a little nutsos there. We're going to hit this button here. We're going to grab derivative, or I could have done, I'm going to do that again. Tab, shift minus. And then we're going to go x, and then var f1 of x. And I'm going to go ahead and move these points off here so that they aren't driving us bananas. Okay, and I'm going to calculate those zeros. So Menu, Analyze Graph, 0 to the left, to the right. And Menu, Analyze Graph, 0 to the left, to the right. Okay, so I'm also going to use 1.880. So this happens at 1.880 and 4.786. Put that in there as well. Okay. So 4.786, 4.786. All right, so now my favorite way to do this would be to get out a sign chart and look at the difference in our signs. So because we're looking for the signs, if we're looking at increasing, we're looking for intervals that have the same sign. So we're going to put a fence at every single one of these intervals. So these are our intervals. We're going to look at the sign of our velocity and the sign of our acceleration. We don't have to pick a t-value because we're just going to use the graphs to help us out here. So I'm starting at 0 probably, and then we've got the first fence is at 7. I could just do 0.7 to represent it. I don't need all those decimals. And then the next one would be at 1.8. And then the next one would be at 3.4 and 4.7 and then 5.7 and then to infinity. All right, so I'm going to start by looking at where we're above and below the axis. So 0 to 0.7 would be right here, so that is below the axis. Notice this value here is 3.4. The 1.8 would be up here, so I am above the axis, or I could just think of it from 0.7 to 3.4, everywhere there I'm above. So from 0.7 to 3.4, I'm above. All right, then it looks like from 3.4 to 5.7, I'm below. And then 5.7 to infinity, I went back above again. Then I'm going to do the other graph. So from 0 to 0.7, which would be, from 0 to 0.7, that is 1.8. So actually from 0 to 1.8, I know I'm above the axis. Then from 1.8 all the way until 4.7, I know I am below the axis. And then beyond 4.7, I know I'm above. All right, so we are looking for times when we have the same sign because we're supposed to be increasing. Oh, that's not what I meant to do. All right, let's try that again. Same sign, doesn't matter if they're positives or negatives, same sign. So we know that the particle, is it the particle? The speed of the particle is increasing on, and you want to use all the decimal places, 0.746 to 3.480, 3.480, I'm sorry, 0.7 to 1.8, not 3.470. So it would have been 1.880. 3.480 to 4.786 and 5.773. They didn't give us an interval, did they? Nope. So to infinity. And you have to tell them why. Because acceleration, so because velocity and acceleration have the same sign on these intervals.